So yesterday we did implementation of different functions related to different operations on a single list, and then finally we implemented the remove before function. And yesterday also I said you that this is one of the tricky operations on linked list. So removing a node before the given node. Okay, and here we made use of two pointers. One was the temporary pointer to traverse the list, and then a previous pointer. And the idea of previous pointer to always point to a node which is previous to the temporary node when it starts the traversing. So initially, in the beginning, it points to the first node as like your TMP or the temporary node, and once the traversing starts, so at any point of time, to whichever node the TMP is pointing to, the preview pointer would be pointing to a node previous to the TMP node or the node pointed by TMP. So that was the idea which was exploited, you can say, into this function, and then we accordingly handled the different situation for the function, and we completed it. So before moving ahead, I think that logic that how does the pointer move in the list when we wanted to traverse the list. So that logic is very important. So what we'll be doing, I have a small presentation, and we will just go through that logic. That how does the temporary pointer move, and how does the preview pointer move behind it, and how effectively it handles the given condition. So for that, uh, come back to your remove last function. So the remove last function is a function which removes or deletes the last node of a given linked list. It removes or deletes the last node of the given linked list. Okay. So here also we made use of this preview pointer. So initially, what we did that we made the temporary pointer to point to the first node by writing tmp equals to h, and then pre equals to tmp. So pre also points to the first node, and then we start with the loop while tmp of next node equals to null. So until we reach the last node, while tmp of next node equals to null. So in a singly linked list, when any node's next pointer points to null, it means that that node is the last node. I repeat, in singly linked list, when a node's next pointer points to null, it means that that node is the last node. So until we reach the last node, while TMP of next node equals to null, what we are doing, prev equals to TMP, and then TMP equals to TMP of next. So before making this temporary pointer to point to the next node, we are making prev to point to temp. Okay. So the moment TMP points to the second node, prev points to the first node. Then the moment TMP points to the third node, prev points to the second node. Then the moment TMP points to the fourth node, prev points to the third node. So this way, your prev pointer is always one node behind your TMP pointer. Okay, prev pointer is one node behind the TMP pointer. That is the logic which has been used or exploited in this function and in another function also. So I just wanted to have a presentation on that logic. So please see here, and I will be directly going to this. Yes, I am interested in traversing the given linked list so that a last node can be deleted. Okay, so traversing a given linked list, and why do we want to traverse? Because we want to delete the last node from the given linked list. So now here the list is pointed by h, as we have seen in the case of a function. If you see here, so the list which we are passing to this function, that list is getting pointed by h. So h is a pointer which always points to the first node of my list. If there is a node in the list, else h will be having a null value if the list is empty. So h is a pointer that will be pointing to my first node. So suppose this is my first node which is having a data 10. Then the next pointer of the first node is pointing to a second node which is having a data 20. Then the next pointer of this second node is pointing to another node which is having a data 30. And then the next pointer of the 30 is null. It means that 30 is the last node of our given list. And what we can see here that our list has got three nodes. The first node having a data 10, second node is having a data 20, and the third node is having a data 30. Okay. And then the first node is pointed by the pointer h. Now in the code, if I come here, so h is not null, so we'll be coming to the else part. And then in the else part, what we are doing, we are making temp equals to h. So now we are initializing a pointer temp equals to h. And the moment we initialize the pointer temp equals to h, here we get one pointer tmp, which starts pointing to the first node because temp is pointing to the first node, which is having a value of 10. So the moment you write temp equals to h, the moment we write temp equals to h, the temp pointer also starts pointing to the first node. Then the second statement in this else block is preview equals to temp. Okay. First statement was temp equals to h, and the second statement is preview equals to temp. H is pointing to first node. Temp also starts pointing to the first node, and then the moment we write preview equals to temp, we get one more pointer, and that pointer also starts pointing to the first node, that is 10. Okay. Then comes our while loop. Now the condition in the while loop is what? While temp of next not equals to null. If the condition is true, you will get inside the while loop. If the condition is false, you will go out of a while loop. Okay. If a condition is true, then we'll get inside the while loop. If the condition is false, then we'll go out of a while loop. So what is the condition? Temp of next not equals to null. Now we can see that temp is pointing to the first node, which is 10 or having a data 10, and temp of next is this one, this pointer. Okay. Now this pointer we can easily see is pointing to this node 20. This is not null. Okay. So the moment this is not null, our condition is true. What is the condition? Temp of next not null. Condition is true. Okay. Now the condition is true. We come inside the while loop. When we come inside the while loop, so here I can see the statement preview equals to temp. Now preview equals to temp. Temp is pointing to the first node 10. Preview equals to temp. So preview also starts pointing to the first node 10. So preview remains same. There is no change. Then the next statement inside the while loop is temp equals to temp of next. Temp equals to temp of next. And I said you, this is nothing but something like I equals to I plus 1. And the moment we write temp equals to temp of next, this is my temp pointer, which is pointing to this node. Okay. Temp of next is this, which is pointing to 20, which we have already seen. It is pointing to 20. Okay. The moment I write temp equals to temp of next, now temp should also start pointing to 20. Okay. So what happens now? Temp gets shifted, and then the temp pointer starts pointing to the second node 20. Okay. Now see here carefully. This is the last statement of my while loop. So we'll again go up. Okay. And then when we go up, we come back to this condition. while temp of next not equals to null. So again, the condition should be tested. If the condition is true, we'll come inside the while loop. If the condition is false, we'll go out of a while loop. So the condition is temp of next not equals to null. Now temp is pointing to 20, this node, temp is pointing to 20. So when I say temp of next, so temp of next is basically this pointer. And this pointer is pointing to a node 30. It is not null. Okay, this pointer is not null. It is pointing to a node. So the condition temp of next not equals to null is true. The condition temp of next not equals to null is true. It is not false. Okay, it is true. So the condition is true. We come inside the while loop, and now the first statement equals to prev equals to temp. First statement is what? Prev equals to temp. So now the statement is prev equals to temp. Now we can see that temp is pointing to this node. Temp is pointing to this node, and prev is pointing to this node. So the moment I write prev equals to temp, now prev starts pointing to the second node. Okay, that is 20. Okay, then we go to the next statement of a while loop. We go to the next statement of a while loop, and the next statement is temp equals to temp of next. So temp equals to temp of next. Now temp of next, as we can see here, temp of next is this pointer which is pointing to my node 30. So the moment I write temp equals to temp of next, the pointer temp starts pointing to the third node 30. Okay, the temporary pointer temp starts pointing to the third node 30. Okay, and the while loop completes here. Then we again go up. Again we check the condition. While temp of next not equals to null. Okay, temp of next not equals to null. See here, temp is pointing to 30, and if I see what is temp of next is this, which is null, So now the condition is false. What is the condition? Temp of next not equals to null. But in this case, temp of next is null. So the condition is false, we come out of a while loop. Condition is false, and now the moment condition is false, we come out of a while loop, and then we come here. Okay. Now when we come here, see here very carefully, what is the situation? The situation is what? TMP pointer is pointing to the last node, and the prev pointer is pointing to the second last node. This is very important for us. The prev pointer, this pointer, is pointing to the second last node. It is not pointing to the last node. That is the most important logic. And once we understand this logic can be used in any of the required functions. Can be easily used in any of the required functions. Now see the next statement. The next statement is what? If h of next equals to null, h equals to null. Now this is to handle the situation wherein we have only one node in the list. So when you have only one node in the list, and if that node is getting deleted, so h would be null. That's why we are writing that. So h of next equals to null. So whether this condition is true for this example, this is my h pointer, and h of next is this. So whether h of next is null? No, h of next is not null. It is pointing to a node. So that condition is false. When that condition is false, we come into the else part. In the else part, you have a statement prev of next equals to null. Now see here carefully. What is the statement? Prev of next equals to null. So it simply means that prev is pointing to the second last node, and I want to make the next pointer of the second last node as null. What do you want to make? We want to make the next point of the second last node as null because we want to detach the last node, which is 30 in this case. So if you see carefully in this case, the last node is 30 and we want to remove it. We want to detach it. So what we'll be doing, the second last node next pointer should be null. Okay. So the moment we write prev of next equals to null, prev is pointing to the node 20. So that node's next pointer should become null and it becomes null. Okay, you can see that. The moment it becomes null, that link which is there between 20 and 30, that link will be destroyed. That link will be removed. Okay, so the moment it becomes null, that link is removed. And then the moment that link is removed, now the last node, which is pointed by TMP, is not a part of our linked list. Is not a part of our linked list, and that's why the last statement after that is to free that node, and that's why we are writing free temp. Now this is very important. The way we have allocated a memory for creating a node or for inserting a new node, in the same way we need to free up the memory whenever we are deleting a node. Okay, so you should not keep the memory as it is. For the C compilers, we do not have something like garbage collection, which we do have in case of Java, in case of Python. So we do not have. So it is a responsibility of the developer. It is the responsibility of the programmer to handle the memory carefully. So whenever you allocate a memory, it is your responsibility. Once the memory has been used, if the memory is not required anymore, so it is our responsibility to free up that memory. Okay. So the way we have used the malloc library function to allocate the memory, the same way we'll be using the free library function to free up the memory. Okay. So free and then the pointer which is pointing to that memory block. So TMP is pointing to a memory block, this one, 30, and we want to free up this node. So since we want to free up this node, that's why we are writing free temp. So this is the mode. This is the mode. Fine. And then finally, this last node, which is pointed by TMP, that will be removed, that will be destroyed. And into our list, what we can see that we have now only two nodes. And this is my complete list, which is having two nodes, 10 and 20. Okay. So this is how the logic of making your two pointers work. One pointer will be pointing to a specific node and another pointing will be pointing to a node just before or just behind that node. Okay. So this logic we have used into this function. And then the same logic we have used in remove before also. But not only that logic, we wanted to improve upon that logic. So if I show you the same, this one. So in this presentation, what you can see that remove before the given node. Okay. So what happens in remove before a given node? First of all, we need to search a given node. Okay. So what we did, we started searching a given node. So for example, if the given node is 30, this one. So I got my list like this. And let me. So this is a scenario. You got three nodes, and suppose the given node is 30, the third node. So what happens that we are finding 30, and 30 is getting pointed by TNP. Okay. Now we need to remove a node before the given node. What is the function? You need to remove a node before the given node. So remove before. So in this here, into this logic, sorry, into this while loop, we are finding the given node. So after this while loop, what happens? That the TMP would be pointing to a given node if the given node exists in the list, and preview would be pointing to a node which is just before or just behind that given node. Okay. So in this case, now suppose the given node exists. So we are coming to this part, directly to this part. Okay. So when we come to this part, what we are expecting that the given node exists and given node was pointed by TMP and pre was pointing to a node just before the given node. So this is my given node 30. So this is my given node 30 and TMP is pointing to the given node and pre is pointing to a node just before this given node. And basically, the idea is to delete this node. Which node? 20. The idea is not to delete the given node. If the idea would have been to delete the given node, then our work would have been done quite easily. Because prev is pointing to a node which is before the given node, we can simply have done prev of next equals to temp of next, then temp of next equals to null and free temp. Done. Deleting the given node. But what we need to do here, basically we need to now delete a node which is before the given node. And that node is this node, 20. We need to delete this node. Okay. Now to delete 20, I need an access of a node which is before 20. Please hear carefully. We need to access a node which is before 20 to delete 20 because for deleting 20, I need to modify this pointer. So when we modify this pointer, then only we can delete 20. Okay. So we need to make, if I want to delete 20, basically what I'm saying that I need to make this pointer for deleting 20. I need to make this pointer to directly point to this node. Okay. The moment this pointer starts pointing to this node, then we'll remove this link. Okay. The moment we remove this link and the moment we make this to null, and the moment you have changed this, so this also have been removed. Now after that, we can simply free this node, free preview, done. Okay. So the idea is what? I do not only want this node, I want a node which is before this. And that's why we had an additional loop to traverse again. Okay. Because we need to now go to a node, which is before previous, which is before prev. That's why the logic is while temp not equals to null, and at the same time temp of next not equals to prev. So basically we are trying to go to a node which is before prev. Okay. So here in this case, you are trying to access this node. Okay. We are trying to access this node so that we can directly say that next of this node equals to prev of next, and then prev of next equals to null. See what we have done there. The moment we have reached that, we have simply written TMP of next because TMP now would be pointing to that node, which is before the prev node. So TMP of next equals to prev, then prev of next, then prev equals to null, and then free the node prev. Okay. So this way, uh, we have deleted a node before the given node. Fine. I hope you are understanding it. It is little tricky, but Practicing it 2 or 3 times, inshallah, will definitely get you through it. Okay, so you will definitely understand it if you just practice it 2 to 3 times. If you take some example list with you of 3 notes, 4 notes, or 5 notes, then you work on that. And if you work for the different condition also, for example, you are trying to delete a node before the first node, then you are trying to delete a node before the last node, or then you are trying to delete a node before any intermediate node. So you should try for all the possibilities. Okay, then any function you want me to implement here? What if we have another node, say 40 after 30, and we want to delete node 30? The same logic would go. Uh, the logic would remain same. No issue or no matter that how many nodes you have, whether you have 3 node, 4 node, or 100 nodes. The logic would remain same. Okay. Any other query into this, or you want me to implement any other function? Almost all important functions we have covered, and I requested you to complete the remaining function by yourself. And there are not many. For example, you can write a function to delete the given node, and you can write a function to delete a node after the given node. Okay, so this way you can do the stuff. Yes, please, we can have a discussion. I'm open for the discussion, and if you have query, put up the query. So uh, I will assume that today we are completing with signaling list. So in the next session, then we can start with another type of list, circular link list, and then the blue link list. Please come forward with any query you have. You can unmute yourself. You can unmute your mic. You can ask a query, or you can simply put your query into the chat box. Still, we have five to 10 minutes because you need to go to another session. I mean to say the students, those who have registered for that soft skill development session, they need to go for it at 12 o'clock sharp. So I will be leaving you by 45. Okay, please come forward with a query. You don't have any query, or you want me to implement any function, so we'll try to implement that function within 5 to 6 minutes. Yes. Hello. People are there. If you do not ask, then I will ask. How can you implement a function to remove a given node? Now, this can be straightforward and simple. You want to remove a given node. Yes. How you will be implementing that? So let me know first. You need to remove a given function, given node. Write a function to remove the given node. What should be the logic? This is our remove last function. What changes are expected? Remove a given node. What I do, I take this function itself, remove last, make a copy of it, then let me put it over here. And let me rename it. This is not my remove last now. I would call it remove given. First is to check whether the list is empty or not. If it is not empty, then only do this part. And I'm not removing the last function. Instead, I am going to remove the given node. I'm not going to remove the last node. I'm going to remove a given node. In that case, I need to have a check while my temp not equals to null, and at the same time, uh, temp of data not equals to the given node, that is k, for example. And here I need the element k also along with the list, the node which we need to remove. So prev equals to temp equals to temp of next. If the node which has to be removed is the last node, sorry, is the first node, in that case, my h would be temp. So if h equals temp, it means that the node which I'm supposed to remove is the first node. In that case, I would be writing h equals to h of next. Yes, h equals to h of next. And then if that is not the case, then else preview of next equals to temp for next. And then free temp, I can say given node remove. One more thing I need to check, if temp equals null, it means that the given node does not exist. So then type a new line, given node does not exist. And the given node does not exist, so I can simply return h after displaying that. So if time equals to null, given node does not exist. If time equals to h, so the given node is the first node, so h equals to h of next. Else, if that is not the scene, then free of next equals to temp of next, and then free temp, absolutely fine, given node removed, and then I would be returning h, fine, absolutely fine. So this should work now. Remove given. And what I do, check it. Remove before is there. I call it remove given. I make it remove given. The fifth option. Case 5 is this one, and instead of calling remove before, I would be calling remove given. Okay, let us check it. Let us check it. Don't have much time. Okay, so it got compiled. It is session 21. I got a file, exe file of session 21. Executed. Let me put some notes. Then 20, then 30. Three notes I have entered. Let me display. Okay, so three notes are there 10, 20, 30. And let me go for the fifth option. And I go for a node which does not exist. So I go for the key value 40. So the given node does not exist. Yes, we are getting a message. Given node does not exist. Fine. I again go for remove the given node. And this time I would like to remove the middle node, that is 20, 10, 20, 30. So I would like to remove the middle node. Let me see. So key value 20, given node removed. We are getting a message. Let's see whether the node has been removed or not. 6 display. So yes, 10 and 30. So the middle node has been removed. And now suppose I want to remove the first node, that is 10. So I go for the fifth option, remove given, and I go for the key value 10. So it says given node removed. Let us see whether the operation has been done successfully or not. Displayed. So yes, the first node has been removed, and now we have only 30, only node. Let me remove that also. Remove given, and I go for 30. It says given node removed. Let us display. It should be empty. Yes, the list is empty. Perfectly fine. So if you see carefully, the single remove function, remove given, is working for all the conditions, and it can remove the first node, it can remove the last node, it can remove any intermediate node. Okay, so that's fine. Okay, we are done with that, and I think we don't have much time now. So I stop the recording, I stop the presentation.